Okay, so this is a video for how to complete the types of series and parallel circuits virtually. So if you were not in class or you still had a few problems to finish, this is how you can complete anything on there and get the same answers that you would have if you did it in class with the white boxes. So first, you need to go to the circuits folder, and my assignment that I'm looking at right now is this series and parallel lab. So when you click on this, you'll see right here is the virtual circuit lab. And then below it, you will see this video that I'm recording right now. So this is the lab you click on, and it should open up an assignment like you see here on the left-hand side. So I cleared my space, and I'm ready to get started. So there are two types of circuits. One is called a series, and one is called a parallel circuit. So basically what you're going to do is you're going to build what's in this picture here on your screen. So main things to have are what's in the circuit on the left-hand side, and then what it looks like is on the right. But since I'm using the virtual lab, it'll look a little different. So if you build it the same way, you should be good. So here, you can see that it has two batteries. So I'm going to put one here and a second there. Okay. You can connect these batteries together like that. Remember, you can drag and drop them together, and overlapping the red circles will cause your objects to link. All right, so the next linked to the battery is a switch. So here's my switch. All right, move it up so it looks like it does in the picture. Then that is connected to a light bulb, which is connected to another light bulb. I'm going to space out the light bulbs here just for simplicity's sake. So I'm going to put them separate like this. And then I'm going to use wires to connect them. So connecting the red to red will create a black. If it is black, that's how you know you got it right. So I'm going to connect this one here. You can click on the red part and extend it so it connects to the second light bulb. And then you use another last wire to connect the final piece of the light bulb down to the battery. So you can move them around so it fits a little better, but again, positioning doesn't really matter. It's just that you have it built right. All right, so let's double check. I have two batteries, boom, boom. I have a switch right here, and I have one light bulb and a second light bulb. Should be good. All right, first it says, trace your finger around the path from the positive terminal one battery to the negative terminal of the next. Is there more than one pathway around? So I'm close the circuit, turn it on. All right, and there we have it. So you can see the electrons are flowing, which are the blue dots, up and around through the light bulb, down, up through the next light bulb, and back down. All right, so the electrons only have one way around the circuit. They're not jumping around from light bulb to light bulb. They are flowing from one to the next. So there's only one pathway, right? So when you look at these light bulbs, all right, how bright are they? So if there's the longer these lines are, the brighter the bulb is virtually. So this one is, I would say, in the middle. All right, so I'd say about a 3 out of 5 on these lights right here. So that shows you. So that's how you do B. And then unscrewing one of the bulbs. Now, since you physically cannot unscrew a bulb here, all you need to do is click on one of the bulbs here and click the scissors for that as well. So clicking the scissors disconnects one of the bulbs, as you can see. So it disconnected the bulb that I have highlighted. And now you can see that both of them went off. So that's right here, unscrew one of the bulbs. What happens? The light bulbs went off. And why is because you are no longer connected together here. These light bulbs are no longer connected, so the circuit is open and broken, which does not allow the electrons to flow from place to place. So that is the answer for C. And that's how you get through the first part. If I went a little bit too fast, feel free to rewind and watch this again. Okay, now that we are done with part 1, we can move on to part 2. So So building a parallel circuit. This one's going to look a little bit weird because we're not building it on the board, but building it virtually is just as easy. Okay, so you can do this two ways. You can scrap and start over. I am going to keep this almost the same, but I'm going to make it vertically. Like if you were to rotate this picture like this, is how I'm going to make it. So here, I'm going to snip this wire and snip out this bulb. Because like I said, I want to keep the basic structure of my circuit the same, so that way it just saves me some time. So if I line up one bulb up here, and I'm going to line up these two right here, all right, this creates a branch of the circuit. Like that. So there's one. I'm going to turn this light off just so I can finish building it. All right, so there is the first branch of the circuit. I'm going to create a second branch by attaching multiple wires to this end so it goes up and around like this. So I'm going to basically rebuild the same thing here. I'm going to pull this over to the side so I can get this in like that. I'm going to attach my bulb like this. I'm going to pull it down so you can see it a little bit better. And then my wire. And now my corner. There we go. So this circuit is basically the same thing as what's in the picture. Okay, now I'm doing this so because you can see a lot of it like this. Right? If you build it, make sure it looks something like this because you have two pathways here. So now when I close the circuit, here is my pathway. All right, so here is my first circuit. Goes through there, and there is my second one that goes up, around, and back. So trace your finger. Do you see if I trace with my mouse, I can go through this first branch, that's 1, and I can go through the second branch, that's 2. So there's 2 pathways. Describe the brightness, like we did in the last problem. I give it on a 1 through 5 scale is the easiest. And then what happens when you unscrew one of the bulbs? So I'm going to click on this bulb, and I'm going to click the cut to unscrew it. And you can see that the second light bulb stays on. And if I did the opposite way, like this, and cut the one up top, you can see that the bottom one stays on. So it does not matter which one you cut, one of them will stay on, and that's important to know. So then when you come down here for number 3, you're going to be analyzing your circuits together. So one tactic you can do on this to make it a little bit easier for yourself possibly is you can build circuits side by side. Now this is nice and an advantage to doing it online because in class you're not able to do this. So I'm going to go real quick and build that circuit again that we had in the first problem. And see if we can compare them real quick. So we had 2 light bulbs connected by wires, and then the wires connected back to the battery. Okay, if I go ahead and close the circuit. All right, so it should be pretty visible here of what the difference is. All right, if you look at the speed of the electrons, you can see a difference. And if you look at the brightness of the lines for the series circuit there and for the parallel circuit here, you can see that they are different. One is brighter than the other. That's the whole point. So I can show you that side by side, here is the difference between series circuit and parallel. For the household question, think about if each one of these lights represented something different. So I wonder if you, no, It's not here. But just pretend that each one represents something different. Like, say, it's a light bulb or a PlayStation or a television in your house or a toaster. If you took one of these out, so like if you unplugged down here, if I'm in my kitchen and I'm on my series circuit on the bottom, and this first light here is my refrigerator, and my second light is the toaster. All right. If I stop using the toaster, what happens to the refrigerator? Same scenario up at the top. If I have this bottom one is the toaster and the top one is the refrigerator, if I'm done using my toaster and I unplug it, my refrigerator stays running. Okay? So that's how I want you to think about it when you do these together, is to think about these in terms of, instead of being light bulbs on this circuit, think about if they were actual appliances in your actual house. So next, when we build the and or circuits, and or, what I want you to do is take a good mental image of what you're looking at here. Okay, so for the and circuit, that's going to be like this one at the bottom. For each light bulb, I'm going to replace it with a switch. All right, so I'm going to cut out this one and cut out this one, and then I can just drag and drop switches in here like this. Cut that, and then put a second switch in there, and then replace the switch with a light bulb. All right, so notice how it looks the same as the other one, but functionally is a little different. I'm actually going to use some wires here so it's a little bit neater and easier to see, because I don't like how the way that's set up. All right, that's a little bit neater. Okay, so I have my batteries like I do here. I have one switch, two switch, one switch, two switch, and I have a light bulb. All correct. So let's zoom in and focus on the bottom here. All right, so pretend that this first switch is switch 1 and the second one is switch 2. When it's on, the switch is closed. When it's off, the switch is up. So think about it like that. So I'm going to turn both switches on, which means put both of them down. 1 and 2. Okay? So then you would write what happens here. So is the light bulb on or not? So it says record what happens to the bulb. Bulb is on. I'm going to take both of them off. I'll click on both of them and open it up. And you can see that the bulb is off. I'm going to turn switch 1 down and leave 2 open. Record what happens, and then I'm going to do the same thing the opposite way. Okay? So that shows you what is happening in each scenario and what you record here. So this is called an AND circuit, all right? And I'm trying to get you to understand why it's called an AND, because in order for the bulb to be on, one thing and a second thing have to happen, okay? So then, does this compare to the series or parallel circuit? All right, and then think about that here. Next, we're going to build the OR circuit. So it's going to look just like this, which is, like I said, I'm going to go up, and I said it's easy to do this if you reuse your circuits. So it's a parallel setup here, and you're going to replace the light bulbs with switches. So let me get rid of this light bulb and get rid of this light bulb. And I'm going to get rid of that switch. So I'm going to hook up a switch in the middle here and hook up a second switch in the middle here. So 2 switches in parallel orientation to each other. And I'm going to throw this light bulb in here like I did the last time, just to make it a little bit neater on the outside. All right, and then we can zoom back in. So here we are. Again, call this switch 1 and this switch 2. All right, when they're both down, what's happening? When both are off, what's happening? When 1 is down and 2 is off, and then when 1 is off and 2 is on, okay, what's happening? All right, and you record what's happening in these boxes. And then, does this compare to the series or the parallel circuit better? Okay, so I'm not giving you all the answers on purpose because I want you to go through and do this, but this should give you a pretty good understanding of how to do each step with the virtual setup if you're trying to finish it at home away from the lab. If you have any questions, please reach out to me and I will do my best to answer them in a timely manner. Hopefully this video helped, and I will see you guys later.